So very good evening to you all. This is Gurpal Singh from Gurpal Education, and as usual, as the convention is there, before speaking anything else or before starting my lecture, I would like to know from you all if everything is visible or can you, am I audible completely? Can you hear me? Is this all? Is this everything working fine? I need quick confirmations from 5 to 7 students. Am I audible to you? Can you please reply? Is my voice completely audible? Is this all working fine? Okay, thank you so much all. I have got the confirmation from more than 6 or 7 students by now, and now I shall start my lecture. And this is going to be very important. The reason being, this topic is not for a particular subjects, although today the topic was for paper second only. Okay, but this topic being very connected or very relevant from research point of view as well. This is important for not only a particular subject, but for paper one as well. As you all know that there is a separate module or the separate subject named research methodology or the research aptitude, in which is the module second for the syllabus of a paper one. So this topic relates to that subject as well. So if you go through from all the things, from whatever I am teaching to you, if you go through from all the things, then studying research can become very easy for you. So today we shall take 2 lectures. Okay, so this is going to be the very first lecture in which we shall talk about some kind of data and some kind of a series, how to make the series and how to produce your data, and what are the different measures of central tendency, which is very important from the point of view of research and for paper 2 as well. Okay, so now I'm just going to share my screen, and before I share it, I would like to request you all that you have to off your microphones and your cameras as well. Okay, so I do not need any kind of disturbance so that it becomes easy for me to teach you. Okay, so this is the detail of a complete topic. Okay, so this is about measures of central tendency, introduction to measures of central tendency. Okay, so we have to know what is the meaning of a central tendency first of all. Although this for the if you you are studying or you are belonging to any stream, not only commerce or management, to any stream, either this is economic or even home science or anything else, still in the syllabus of post graduation of all the streams, you have to go through from basic statistics, you have to go through from basic economics as well. Okay, so these things we have to go through. I think I'm getting trouble from Redmi phone, so just do not create any kind of issues. Okay, so who is this Redmi? Kindly don't trouble, please control your cell phones. Okay, so this is about measures of central tendency. Okay, so in all the streams, this is taught. This particular subject is taught. This is measure of a central tendency because the subject of statistics and the economics is prevalent in all the streams, not only for commerce and management. Okay, so as usual, before starting my lecture, as I on daily basis, I ask you some questions or I give you some examples on the basis of which we start our lectures. So as usual, today I shall do same like that. I shall ask you some questions. Okay, I shall ask you some question, and you are not supposed to answer in chat box or anything. You just have to think in your mind only. I know your answer. I already know your answer because I, being a teacher, and having the experience, I know what your answer shall be. Okay, I shall also give you answers of these. So suppose this is your first day. This is your first day as a student of any institution. You have taken admission in graduation. Suppose you have taken admission in Bachelor of Science or Bachelor of Commerce, or this is your very first day. Okay, you don't know anyone. And when you return to your home in the evening and your parents ask you how many students were there, you have not counted them. Okay, you have not come because this is the very first day, you have not counted them. And if they are asking you how many students were there in your classroom, what your answer shall be? Your answer shall be, mom or dad, probably there were 30 students. I think this is my estimation that there would be 30 students. Okay. Suppose you are wandering in the market, okay, and you had been there for 2 hours. For 2 hours, you were in the market today. And by the time evening, if your parents or your siblings ask you, how many cars did you see in the market? You never count these, okay? But your answer would be, I saw probably 15 or probably 20 or probably 25. This is your estimation. And on the basis of your estimation, you tell these, you answer these kind of things, okay? Suppose you have gone to a shop, okay, shop of a footwear, and you saw a number of pairs of shoes that shop contained. And when you return to your home and anyone asks you the question, how many pairs of shoes the shop contained, okay, for size 6 inches, okay, how many pairs of shoes were there, how many boxes of shoes were there, what would be your answer? You have never, you, these kind of things you don't count ever, but you can answer on the basis of your estimation. Like these estimation can be made on the basis of the size of the shop or size or the number of shelves in the shop. Okay, what your answer would be? Your answer would be, probably there were 100 pairs, 100 boxes, or these kind of things. So all these answers, like there were 35 students or there were 20 cars or there were 100 boxes, these are on the basis of estimation or on the basis of average, on the basis of average. Okay, so this is how the concept of average emerged. Okay, this is how the concept of average emerged. It's not, it cannot be credited to a specific giver or the specific personality, that the average concept has been given by a specific person. There has not been any kind of specific personality or the propounder, we can say, for the average concept. Okay, so this is how it emerged, and this is known as the concept of central tendency. Central tendency, what is this? This is means we always try to think about the centrality of everything. Okay, we think about centrality, we never know, sometimes we never know what can be the possible number of something, but we, on the basis of our mindset, on the basis of our knowledge, we give only an estimation, and that estimation is the base from the centrality or central tendency. Okay, this is how it emerged. Okay, you never know, you never count anything. Okay, but you can make your estimation. How do you make this estimation? Do anyone ask you? Do anyone ask you? Do you, are you being asked by anyone that there were 30 students and you have to go to go in the evening to and to tell your parents that there were 30 students? No one tell you, but you apply your own mindset and you answer that probably maybe there were 30 to 35. This is how the concept of a central tendency emerged. Okay, so this is what we have to go through. So now, as usual, I have written here the concept of a central tendency. And even before going to that, I would like to answer you that central tendency is almost similar to average or mathematical average. Although there are some other concepts like mode and median as well. But when we talk about only central tendency, that means on average. On average. And average we have gone through. If you are very regular with the explanation videos, number of times the question from average is being posted in those tests, and I have told you its formula number of times while explaining that specific question in the explanation video. So you have to be very touch in with all the things we are providing to you. Okay. So central tendency is the crux or the similarity with average. So now this is measures means method. Okay, measures means method, and central tendency means average value of any statistical series of any statistical series means simple, a simple series. Okay, like we deal on the daily basis, we calculate your marks and we declare the result in the WhatsApp. Okay, so there is a list of all the names and the numbers they have obtained in a specific test. This is called a series of numbers, or series of marks. So this can be known as a data series. This is very simple. This is a data series, or this is known as a statistical series if I want to do further research on that. Okay. So now we can say that central tendency means methods of finding out central value. Central tendency means applying the methods to find central value or average value of a statistical series. And statistical series, I have already taught you what does it mean. You can take the example of the daily result being posted by us in the website, in the WhatsApp group. So this is just just a simple explanation, and this has been given by this in the notes as well. All the explanations and all these kind of things have been given. Going through is very easy for you because we write in a very simplest language. You are not supposed to cram the name of the individual person, because from this particular topic in paper 1 question can be asked, but in case of paper 2, this I am teaching this just to clear your concepts, because if your concepts are clear, only then we can go further with the central tendency concept. So JP Guilford has pointed out that an average is a central value of a group of observations or individuals. So he is just saying that average is a central value. You have got, somebody has got 1 mark, then then the other one has got 2 marks, the another one 3, then 4, then 5. These are the marks of 5 individual students. If I make sum of these all the numbers, okay, so that comes to be 15. And if I divide this by total number of observations, these are 1, 2, 3, 4, 5. So if I divide this by total number of observation, and then I shall get the average, and this average is known as a central value, and this is concept of a central tendency. I think you have understood this completely if you are very touch with each and everything being provided by us. Then in this slide, I have just written it blank because I wanted to write this example on this slide, but now I think the purpose is completely over. Now we move further. Okay. So no, still we can use this. How? We have to differentiate the series. We have to differentiate the series. Okay. Only then we can understand the concept and the subject matter of all the systems of a central tendency and the dispersion topic. Okay. And the series, statistical series, can be divided into 2 parts only. Okay. So statistical series, I hope you would have understood that statistical series is a series containing data points only, data points. Okay. Like in this example, I have given it, this single marks of a single student is known as a data point. Okay, this is known as data point. And the combination of all the data points makes the statistical series. Okay. So statistical data or statistical series can be differentiated into 2 parts. The first is individual series, and the second one is frequency distribution series. Okay. Frequency distribution series can further be divided into 2 parts. The first are univariate, and the second one is bivariate. Okay. And univariate can further be categorized into 2 parts. The first are discrete series, and the second one are continuous series. Only this thing you have to remember. Okay. And nothing else. Continuous series. Okay. So only this table you have to remember, although some author writes that there are three kinds of series, only individual, then discrete and continuous, and none kind of univariate or bivariate exist. But you have to study this table as I am teaching to you, okay? Because you have to follow all the instructions being given by us. You are not supposed to make any kind of Google searches for that. We have already done all the analysis. On the basis of that, I am teaching you, okay? So statistical data you have understood from me. So series you have understood from me. Okay. So differentiation of a series can be made into two parts. The first are individual series and second one are frequency distribution series. And this table will be as it is recorded, and it will be uploaded in the channel as well, because this video is going to be uploaded. I'm going to explain each series in detail to you right now in the coming slides. Okay, so you do not need to be worried about your basics. I shall make each and everything clear. So first is individual series. What is this? Under this method, the values of all units are shown separately. Only one parameter is shown in a sequence form. None series is given. Okay, so I assign the marks on daily basis. This is an individual series. This is an individual series. How this is an individual series? Because it contains only one parameter, only one variable, and this variable is marks. This variable is marks. Only one variable is contained. So this is an individual series. Okay. So individual series means a series in which only one parameter or one variable is contained. This is known as individual series. I have given example in this way. So here is written code number of students. Okay. Like we declare the result, we show name, and the second is marks. We assign this way. And statistical series, number series, from our point of view, individual series is only marks on. And there in this example, weights have been given for all the code numbers, weights. So this is the series of weights only. Okay, so this is the series of weights only. You cannot make any kind of statistical inferences with the code numbers. You can use only weights for your statistical purpose. So this is the reason why this series is known as individual series. So I hope you would have understood that if a series contain only one parameter or one variable, this series will known to be individual series. So we move further. This is frequency distribution. Before understanding frequency distribution series, you have to understand the terminology involved in the frequency distribution series. Okay. Only then you shall be able to understand the concept of a discrete and frequency distribution or continuous series completely. Okay. You have to understand their terminology. And let me tell you, I am just going to start this right now. You have to understand, or you have to listen me very carefully. The only reason is from a single point, the question can be asked. I'm telling you from my experience. November 2017, one of my question was wrong, and it was asked from this particular topic. Okay, so that's why whatever we teach you and whatever the analysis we have done, you have to understand all the things in a very detailed manner. You have to listen me very carefully. So I am going to explain you right now what are the different terminologies contained in the frequency distribution. So first one is a variable. Variable can be anything which varies in magnitude. Okay, like in a data series, marks is a variable, then height is variable, then weight is variable. Okay, anything. So these kind of a variable which can vary, like marks can vary every day. The students do not get consistent marks. Some day they get 2 marks, then 4 marks, then 6 marks, then 8 marks. So they vary in the magnitude. So this is called a single variable. Okay, so the next is a discrete variable. Discrete variable are those variable which are exact or finite or cannot be expressed in fractions. Okay, if I'm asking you how many students are there in your classroom, you shall tell me they may be 30 or 32, or they may be 34, they may be 36, they may be 40. You can never say that there are 32.5 students in my classroom. Okay, so this cannot be the possibility. And if a number cannot be expressed in fractions or decimals, then this number is known as a discrete variable. So I hope you would have understood that completely. If I'm saying you number of students in your classroom, then this variable is known to be as a discrete variable, because this cannot be represented into decimal numbers. So variable you have understood, discrete variable you have understood. Next is continuous variable, the variable which can be expressed in fractions or decimals. Like I am asking you, what is your weight? It cannot be exact. You can tell me 55.5 kilograms. Okay, so if I'm asking what is your height, you can tell me that this is 5 feet and 6 inches. Okay, so you can tell me this. This is in fractions. If any variable can be represented in fractions, this is known to be continuous variable. The variables which can be expressed in fractions or decimals are called continuous variable. Okay, so then series, from the point of view of frequency distribution, series are of two types only: discrete series and continuous series. Okay, that you have to remember only from all these lines. Okay, so we move further. The frequency distribution has two kind of distributions. Further, I told you that this is univariate and bivariate. Univariate and bivariate, and you should be concerned about univariate only. Okay, because in this slide, when I taught you, I wrote that univariate contains discrete and continuous, although bivariate also contain, but this is not for your level. This is not, this is for extended level. Like this is used for researchers only, okay, because they have a number of variables. And from our point of view, from our study, we should be concerned about univariate variables only. These are discrete and continuous. So now I am going to explain a univariate, but it's not that I shall not explain a bivariate. I shall explain this as well. So univariate frequency distribution is of two types. I think individual series, you have understood this completely. The series which contains only one variable, and one variable contains different data points, this kind of series is known as individual series. Now discrete series. Discrete series is the series which involves, which includes a discrete variable. Discrete variable I have already taught you, the variable which cannot be represented into fractions. Number of students in different classes. Okay, so number of students, there can be 30 in one class, 34 in second class, 36 in the third class. So in this way, these kind of that variable is known as a discrete variable. And if their frequency has been given, then this combination of two makes a complete discrete series. I tell you how. Okay, so this is a discrete series in detail. Let me explain you. The series dealing with the discrete variable means which cannot be represented in fraction or decimal. Okay, this is known as a discrete series. The discrete variable refer to the character which cannot be expressed in fraction, or it is a fractionless variable. There will be either one employee or two employee. Very simple example. If I'm asking you how many employees are working in a factory, you can tell me there are two employees, there are four employees, there are three, there are five or six, anything. You can never tell me there are 4.2 employees working, because human being cannot be made half. This is very common sense. Okay, so this is the example of a discrete series, discrete data series, in which items have been given like 5. These are data points of a series. Okay, an example has been taken. These are different data points. 5 is there, 10 is there, 20 is there, 40 is there, 50 is there, 60 is there, 70 is there. Okay, so these are all data points, and below has been given their frequency. 5 occurs 2 times, 10 occurs 5 times, 20 occurs 1 time, 30 occurs 3 times, 40 occurs 12 times, then 50 0 times, 65 times, and 77 times. So in the series where two things have been given to you and one variable is a discrete, so that series is known as a discrete series. Okay, we can make an individual series a discrete series as well. I am giving you very simple example. Okay, how to convert individual series to a discrete series. Today I shall, when I declare the result, you make the list of the students who have got 2 marks. Then make the list of the students who have got 4 marks. Then make the list who have got number 6, then 8, then 10, or then 0. Then you can find how many students have scored 2 marks. There would be approximately 10, there would be 12, there would be 14, there would be 16. So this is known as a discrete variable, because we never assign marks in fractions, like we never give 2.5 marks or 3.5 marks. And this thing, that how many times 2 is occurring in the result section, then this is occurring for 10 times. This is known as its frequency. So I believe that you have understood the frequency from my side, and I have explained in a very elaborated manner. Okay, so you have to make the items and you have to check how many times they occur in a series, and the number of times they occur is known as their frequency of occurring. Okay, so this is about discrete series. You do not bother, everything shall be provided to you, like recorded lectures will be there, even if, but actually we have to understand this concept very clearly. Okay, and remember me, don't solve any numericals. Don't solve, you will waste your time. We have a lot of things to do. None kind of a practical shall be asked in the examination, otherwise you shall not be able to complete statistics even in three months. Okay, so now I move further. This is continuous series. Okay, series dealing with the continuous variable is continuous series. It can conceive any fraction value within a range. For example, your income, it can be then you can say that it is 1.2k. Okay, then you can say it's 50.5k. Okay, then weight, then profit, then length. Okay, length of any object, these can be represented in fractions or in decimals. So now all the values which can be represented in decimals, then these represents the continuous series. So in this example, so the continuous series has its own terminology. Okay, continuous series has its own terminology. So the first one is, so first of all, let me show you a continuous series data. This is the series. We can write it that it can take any value between 0 to 5. First item can take, the second item can take any value between 5 to 10, second can 10 to 12, then 10 to 20, then 20 to 30, and then 30 to 40. These are the items. They can take value in any range between 0 to 5, and their occurring frequency is 2, then 5, then 1, then 3, and then 12. Okay, so this kind of series is known as continuous data series, because it can contain any value between 0 to 5, then 5 to 10, then 10 to 20. Okay, so now it has its own terminology. The first one is class. Okay, each stated interval is a class. So here 0 to 5 is a class, 5 to 10 is a class, 10 to 20 is a class. Then class limit. Okay, a class has two limits, like lower limit, upper limit. You could see that here is written 0-5, then 5-10. So the first, or this limit, is known as lower limit, and the second limit is known as upper limit. So this is lower, this is upper, this is lower, this is upper, this is lower, this is upper. So these are known as limits of class or class limits. Okay, one is upper limit, and on the other hand there is lower limit. Okay, so these are very easy to understand. I have just written some lines which I have already explained you while giving this example, like lower or upper. So these are the two terminologies. The third one is class interval. The difference between limits is known as class interval. Okay, 0 to 5, then 5 to 10, then 10 to 15. They have difference of 5, 5, then 5, then 5. And this difference is known as class interval. And this is represented either as I or C. Okay, so this is about class interval. Then This is very important topic coming right now in the terminology for finding how much should be the level of class interval. There has been a very renowned professor known as H. Sturge, and they have given a formula for finding the class intervals, and you have to remember this formula as it is. And you are not supposed to solve the practicals of these, because practicals shall not be asked in the examination from this particular topic. Okay, so why I have written that? Because mine was wrong in 2017. Okay, at that time I had not gone through. I thought that this topic is not going to be that much relevant. Okay, but this particular formula was asked. Okay, there cannot be any specific explanation of that. This is very simple. This is k is equal to, k means interval, or this value k should be equal to 1 plus 3.322 natural logarithm of 10. Okay, so this is the formula for finding or obtaining class intervals. So I have taught you this. Then this is the concept of mid values or class marks or class midpoints. Okay, mid values. Though this is the next terminology. That means mid value, like 0 to 5. 0 to 5 has a mid value of 2.5. How? You have to make sum of both the limits, the lower limit and upper limit, and you have to divide it by 2. When you're dividing, you get their class midpoint. Like same, 5 to 10, that is 15 divided by 2, 7.5. This is known as mid value. Okay, so this is the concept of mid value or class mark or class midpoint. So I have taught you this as well. Only lines are written. These are already written in the notes as well. We are going to provide you in this day today. Okay, then class frequency. Frequency of the certain item is known as class frequency. I have already told you that number of times a certain item is occurring is known as its frequency. Okay, so this is 0 to 5 class item is occurring for 2 times, so that means 2 is its frequency. So 5 to 10 is occurring 5 times, so this is its frequency. So this is the concept of frequency. Okay, so now we have to move further and we have to find what are the different kinds of continuous series. Remember me that we have already understood individual series, then discrete series, and the last one is continuous series, which I have already taught you. But there are some different examples or different types of a continuous series which you have to understand. Okay, the first is inclusive series. Okay, this type of a series is made in case of discrete variables. Okay, let me tell you this. If you see this kind of a question, this is known as inclusive series. That means the highest number is included in this item itself. Okay, and this is a differentiated between differentiated with the second item. Okay, like here is 10 to 19, but the second item does not start from 19. It is starting from 20. One number exceeding from the previous one. One number exceeding from the previous one. One number is again exceeding from the from this number. Okay, so this kind of a series which includes the highest value in itself only, this is known as inclusive series. Under this method, an item whose value is equal to upper limit is included in that class itself. This is a very obvious and easy to understand. The second one is exclusive series. This is completely opposite to inclusive. So this is like the next series start from where the previous one ends. Here is 20, here is 20, here is 30, here is 30, here is 40, here is 40. Why this is so? The higher number is not included in the first item. This is included in the second item. If there comes 30, then 30 shall not be included in the second item. It shall be included in next item. So this is that an item whose value coincide with the upper limit of a class is excluded from that class and is included in the next class. So this is the crux of exclusive series. Then open-end series. If this kind of information is given, like lower or upper limit of any item has not been given, then this will be known as lower, or this will be known as open-ended series. Okay, when some class intervals are not given. So next, cumulative frequency, when cumulative frequencies have been given. Okay, so here is the example of that. I'm finding that if the frequencies, instead of a frequencies, cumulative frequencies is given, like 2, then 2 plus 5 7, then 7 plus 1 8, then 8 plus 3 11, these kind of frequencies have been given. So this kind of series shall be known as cumulative frequency distribution series. So I hope you would have understood all the concept completely. Okay, so there are, I think, only two items left. This is the mid value series. The first one is mid value series. That means if the series is containing mid values only, okay, as the class interval, like I told you, 0 to 5 is 2.5, 10 to 15 is 7.5, then this will be known as mid value series, in which mid values have been given only. And the last one is bivariate, in which instead of one variable, two variables have been given. Okay, for example, marks in statistics and marks in economics, these have been given separately. So these kind of series shall not be bivariate series. And you are not supposed to go through in detail for this. Whatever I wish to teach you, I have already told. The next lecture shall be taken after 10 minutes from now. So you have to be very careful of what I am teaching to you right now. You have to keep this all in mind. So we shall meet after exactly 10 minutes. Thank you so much for listening in.